Hey guys, welcome back to the channel. Today we're looking at day 3, toboggan trajectory. So let's read through this problem and see how we can approach it. With the toboggan logging problems resolved, you set off toward the airport. While travel by toboggan might be easy, it's certainly not safe. There's very minimal steering and the area is covered in trees. You'll need to see which angles will take you near the fewest trees. Due to the local geology, trees in this area only grow on exact integer coordinates in a grid. You make a map of your puzzle input of the open squares and trees with the hashes you can see, for example. Okay, so this is a map that we make. These aren't the only trees though. Due to something you read once involving arboreal genetics and biome stability, the same pattern repeats to the right many times. So if this is our map, all the rows in our map, then it repeats horizontally many times. You start on the open square, the top left, and you need to reach the bottom, below the bottommost row on your map. The toboggan can only follow a few specific slopes. You opted for a cheaper model that prefers rational numbers. You start by counting all the trees you would encounter for the slope 3, 1. From your starting position at the top left, check the position that is right 3 and down 1, and then check the position that is right 3 and down 1 from there, and so on until you get past the bottom of the map. The locations you check in the above example are marked here with 0 where, or O where there was an open square, and X where there was a tree. Okay, so if we start here, then we go 1, 2, 3, down 1, 1, 2, 3, down 1. And so on and so forth. Okay, and then obviously when we get to the edge of the map we've made, we repeat it and we continue going until we get to the bottom map of the map. Okay, in this example, traversing the map using the slope will cause you to encounter 7 trees. Starting at the top left corner of your map, follow the slope of right 3 and down 1. How many trees would you encounter? Okay, so let's put our input into the program. Okay, actually let's make a program first. Call it day3.cdb. And let's do day3 input.h. Let's do that just so we don't have it dumped into our file. And then we're going to say S actually, yeah, let's do it. Let's put some of these here, and then let's do S in the line here. Okay, so now there's strings, and then let's do std vector probably include vector. Actually, I'm going to do this properly. Okay, and then we'll say map equals boom. And, okay, now we have our input set up. Okay, so map, let's quickly do feel like typing std over and over. So let's do for auto s map. I shouldn't call it map. That's a little confusing. And then we'll say, I did not find it. What the hell is this? Alright, so what we need to do is write an algorithm that's going to go through this map and make sure that we can keep moving down and to the right until we reach the bottom row. Okay, so number of rows, let's num rows equal to map dot length dot size. Okay, because we know the total size of our map is obviously the number of rows in that map that they give us, but the total width is infinite. It has to keep looping. So I'm guessing it's some kind of modulus operation. So what we need to do is say we're going to say const. So let's use integers. Int section width is equal to, let's take any one of these. So let's take the first one dot length. Okay, so we know how many characters are in a single section width-wise. Now, what needs to happen is if we're moving x, so let's just call them x and y positions. So let's say const int move x equals 3, const int move y is equal to 1. So here we're saying we're going to be moving, this is what we're going to be moving by. I'm guessing if there's a part 2 to this, they're probably going to ask us to change it. So we're going to factor that in and be able to move like an arbitrary number of times to the right and down. So what we're going to do is set those variables that way and not hard code any of that stuff inside our actual algorithm. And then what we need to be able to do is continuously move over and over and repeat as we repeat the width of each map row as we keep moving further and further to the right, which is pretty easy with modulus. So we can just say if we want, okay, hold on, should we just loop through this here? Let me quickly think about this. So we're going to start, okay, we're going to have a start position. So int x, y equals 0. Let's do it like that. Let's make sure we can compile. C++ minus ga3.cbt. Okay, alright, so we're set up to compile and run our application. And I'm actually going to set up the running with LLDB, as I like to do. And then, okay. Alright, so we start at X and Y. So what we need to do is keep moving to the right and down, and then keep counting the trees. So let's say we're going to start by moving. How are we going to start? We're going to start with do they count the first square? The first square is always open, right? Let's start here. But it's not guaranteed to be open. You start on the open square. So let's just do this. Int tree count equals 0. And now let's say do while y is less than map.size. So as soon as we hit map.size with y, that means we've reached past the last row, right? Because row 0, row 1, row 2, etc. So we're going to start at 0, 0, and then we're going to be moving this way. We need to be able to move infinitely to the right, but once we get to, what is it, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So once we get to index 10, that means we're at row 11, that means we're done. We've reached past the bottom of the map, which is what I'm pretty sure they said. So right, and then check the position that it's to the right and down from there, and so on until you go past the bottom of the map. Right. So as soon as we get to a row that doesn't exist, then obviously we've finished doing what we're doing. And like I said, we got to keep moving to the right. So first thing we're going to do is we're going to check if the current square is offers every day. There's a sale and an offer. Okay, first thing we're going to do is we're going to actually, let me quickly disable my notifications here. I don't remember how to disable them. Yes, I do. We're going to set this for 4 hours. Okay, first thing we're going to do is we're going to check if the current position is a tree or an open space. But before we do that, we have to be able to map our current x position infinitely. So what that means is that because x is going to keep growing, we need to say, let's call it read x is equal to x mod section width, right? Because if we go, what is our width here? Well, let's just use this example shorter. So let's say our width is, what are these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's, did I count that one? 4, 8, 3, okay. So there's 11 there. All right, because there's 11, if x ends up being 12, then we need to say 12 mod 11 will give us 1. So that means that we're now back here, right? If we're at index 11, mod 11, then we're back to the beginning, right? So 0, 1, 2, 3, 4 until we reach 10. Once we hit 11, then we need to be able to wrap back around here. So what that means is that our read position needs to be x, the current x position, like global x position, mod the section width, which as soon as we hit index 11, we wrap back around to 0. So that's going to be our read x, and just for consistency, we're going to say read y is going to just be our y position. Or we don't even need that, we can just keep reading y. Okay, now yeah, okay, whatever, let's just do that. Now let's say we need to read a character, and that character is gonna be We're going to get that character by saying map at y, and then we're going to, that gives us a string, and then we're going to say read x will give us a character, and then we'll say c character. I don't like to be lazy with variable naming. It'll give us a character. Let's put some consts because I like consts. And then let's just print it out. Character. And let's put a little space as we do that. And then just, yeah, let's see. Oh wait, we have to also increment. Okay, let's do x plus equals move x. So this is how much we're moving. Y plus equals move y. So now we need to shift. And obviously once we've moved, and then we're like, oh, and now we're past to the bottom of the map, we just break out of this loop. And let's put a little C out here, all done. Or let's not, because then I have to format the other one. Okay, let's compile, that compiles. Oops. All right, so let's see if that's accurate. Let's look at our input. 1, 2, let's make that bigger. 1, 2, 3, down 1. 1, so what do we have? We have this, then boom, we have a bunch of these in a row. 1, 2, 3, down 1, 1, 2, 3, down 1, 1, 2, 3. This guy's gonna hit all trees. 1, 2, 3, down 1. I think we're in good shape here. Okay, let's count them. If character equals that, then we're gonna tree count plus, and then at the end, let's print the number of trees we're gonna face plant. Count. We're going to say tree count in trees encountered, and then in line. Okay. 282 trees encountered. All right. Did I do this right? Why does it feel like this was easier than I anticipated? Actually, I have to zoom in now. So they just keep looping. I think that's it. Alright, let's give it a shot. That's the right answer. Bam. Okay. So that was very easy. Continue to part 2. In this example, okay, the first half of this puzzle is complete, provides 1 gold star. Time to check the rest of the slopes. You need to minimize the probability of a sudden arboreal stop. After all, great, okay. Determine the number of trees you would encounter if for each of the following slopes you start at the top left corner and traverse the map all the way to the bottom. That's the slope we've already checked. In the above example, the slopes would find 2, 7, 3, 4, 2 trees respectively. Multiply together these, produce the answer. What do you get if you multiply the number of trees encountered on each of the slopes? Determine the number of trees you would encounter if for each of the following slopes you start at the top left corner and traverse the map. Okay, that's what we're doing already. And then here we're just moving down diagonally, and then the one we've already done. Okay, in the above example, these slopes would find 2, 7. Okay, let's try. Okay, this makes no sense to me. But okay, let's make this a function. X, 8, y. Let's do this. Okay, we obviously need these two here as well. Okay, and now we can just say let's return tree count. Okay, and we can just call count trees. Okay, for example, these. Oh, so I'm crazy. It's because it's their test data. It's not looking at my data. Okay, yeah, that's why I'm confused. I forgot that they have their test data here, and that's why they have such low numbers. I'm like, how is this what I already checked? We got way more than that. But yeah, I'm just not paying attention. Okay, so what we need to do then is just call our function for each of these, and then keep count of that. So let's let's do should I just call it over and over instead of getting fancy? How many do we have? 1, 2, 3, 4, 5. Okay, so let's just say results 5, and then initialize that all to 0, and then let's just say results at 0 is equal to count. Let's go to this count trees 1. What's going on with my editor? 1 and 1. Result at 1 is equal to, let's do 3 and 1. Result at 2 is equal to 5 and 1. Result at 3 is equal to 7, and then 1 and 2. 7, and then 1, 2, oops, and then 4. Okay, so now we should get these numbers, and then product equals 0, and then 4 int n in results. Let's just say product times equals n, and that should multiply all the numbers together, and then see out. Let's just print our product. So get all of our results, and then we initialize this to 1 so we don't divide by 0, obviously, and then we loop through all of the results. I mean, I could have just done something even simpler, but I don't know. I do these things. Don't ask. I could have just multiplied these all together. Like, I could have done, let me just do that. I don't know why I'm wasting my time. Int product equals and then we can just say times I don't need to overcomplicate this, times there. I know someone will point this out and go, why did you do it so fancy? Why are you... Okay, there. Alright. Happy, Rocco? So, I know I would have gotten called out. Okay, so, let's just make sure that these are, why are these, it doesn't normally indent things like that. I might get the sites to indent like that now. Okay, so we're calling it for each one of those positions, 3, 1, 5, 1, 7, 1, 1, 2, and we need to just multiply those together and get an answer. Okay, are we compiling? Yes, we are. What do we got? 3, 2, 4, 4. Where are those? God, it makes me nervous copying these numbers in. Let me just make sure. All right, so let's quickly check our math. What do we got? 53 times 282. I know it's very simple, but I just want to make sure I didn't mess up anything stupid. 958, 8, okay. What is that? All right, so how many trees you would encounter for each of them. I'm always nervous when they seem like they're too simple. Determine the number of trees you would encounter if for each of the following slopes you start at the top left corner, traverse the map all the way to the bottom, which we already know. In the above example, the slopes would blah 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 blah. 2 times 7. And, okay, so they're just multiplying these together, right? And then what do you get if you multiply them? Let's just see. That's the right answer. Okay, that was surprisingly easy again, but I'm glad we solved it. And yeah, I think we're done here. All right, thanks for watching, guys, and see you in the next one.